Hey guys, welcome. Today we're going to be talking about Docker. We're going to walk through an introduction to the Docker software, container-based software, and we're going to build our first container. This is going to be a very low-level tutorial today, which I'm hopefully going to build on in additional courses down the road. So let's start off with, what is Docker? Well, Docker is a tool designed to make it easier to create, deploy, and run applications by using containers. But what is a container? Well, a container is a package containing all of the parts that the application needs. So if you're using like Spring or Spring Boot, that boot project is essentially a self-contained container. It's a Tomcat server running your applications, which you can then kind of build up and put out as a Docker container, Kubernetes container, or any type of container to use for any of the container-like applications out there. These include things like libraries, dependencies, jars, wars, could be .NET files, could be other projects. It also makes it easier for developers to ship out their entire project as one package. So they don't have to send out multiple dependencies. They can basically get it working on their local machine in one development environment, package the whole thing up, and they know that that container will run on any other server or any other tool that runs container packages. Containers are not VMs. And here's why containers are not VMs. So the typical VM model, you have a machine, a server, you have your host operating system like Windows, Mac, and then you install a tool, either VMware or VirtualBox, which allows you to install separate operating system instances, which are VMs. So that gives you these different guest OSs. So you could have a VM for Windows, you could have a VM for Linux, you could have another VM, say, for Mac, or like you could have two different flavors of Linux. You could have Ubuntu and Fedora. But each of these have their own binary and libraries, and each of the apps are deployed separately. Whereas containers are isolated. You have Docker here just sitting over on the side, whereas instead of being at the bottom level, they share the same host OS, which in this case is typically a Linux distribution, and they're running on some server machine.
Okay, one option nearby is bed and breakfast.
Sorry about that. And then here you can see that instead of separating binaries and libraries, you now have your binaries and libraries are now shared across all of the distribution, the Docker host server here. So you can have apps A and B sharing these binaries and libraries, and then you can have app B, these 4 instances of app B sharing the same binaries and libraries. Typically, virtual machines will run any software that runs on a specific bare metal hardware while providing isolation from the real hardware. So you can actually configure each of these VMs to be for a specific machine. So you could have one VM instance with, say, 2 to 4 gigs of RAM. Another one could be 1 gig of RAM. And then you could play around with the different binaries. So you could have, say, 2-core processors. You could have a 4-core. You could have 8, 9, and you can play around to kind of see what type of machine you need to run your applications. A VM typically will host multiple applications with a mix, which may vary from over time, whereas a container is typically one and done. So you'll typically build a specific application within a container, and that gets deployed, whereas VMs are constantly being rotated and changed, or have multiple instances loaded on them. Containers typically have applications running in container environment share the underlying operating system, as you can see here. VM systems can run different operating systems, which we saw over here. And it's also possible to have a fixed set of applications in a single container, as well as the VM. But typically, your containers are going to be one application at a time. So it's a very lightweight distribution container. In today's demo, we're going to cover how to install and set up Docker. We're going to go over some of the basics of the Docker command line interface, and we're going to look at packaging and deploying a simple Helloworld Spring Boot application to Docker. Before we get started, though, we need to go out to the Docker community and download the community edition of Docker. There is an enterprise edition for enterprise companies that requires a license fee and you get support and all that fun stuff. We're also going to get Kinematic, which is currently a beta kind of dashboard, which allows you to manage your containers. We're going to use Spring STS, which is just Spring's Eclipse build to build our project. And within the Spring STS, it's going to include the Maven 3.3, and we're going to use the latest JDK 1.8. I'm not jumping to 1.9 yet because we're still working out some of the bugs with their current deploy. All right, so we're going to jump out and jump right into the demo here. So to start with, you can get Docker by going to www.docker.com. And on the main page here, you can get some more information about what Docker is. At the bottom, way down here, they have some training information. They have a pretty good knowledge base. Basically, also some standalone documentation and some additional resources. It is open source, which is pretty cool. But if you want to actually get the product, you click Product. And we want the Community Edition, so you just go to Community Edition, go to the Downloads, select your flavor of Docker you want. Since I'm on a Mac, I've already went ahead and downloaded the Docker Community Edition for Mac. You can also get it for Windows, Debian, CentOS, Fedora, pretty much almost any flavor. They also have one for AWS, which is kind of cool because they also have an AWS container that simulates what you have on the AWS store or on the AWS on Amazon's AWS for their cloud distribution. So you could actually build it locally, test it, and then deploy it to Amazon. But today we're going to stick with the Docker CE for Mac. It is a little different than the Windows, but not by much. Just some of the windows look a little different just because it's a different operating system. The other thing you'll need is the download the latest STS. The latest one was just released, 3.9.4. This comes with the latest Maven, and I've already downloaded and installed the Java JDK, which if you don't know, you can download that from java.com download. But we want the actual SDK, so you want to actually get the Java SDK. So you actually want to go to the Oracle site. So if you went to the java.com, you're going to get the runtime. If you want the development kit, you come here and you can download the development kit of your choice. Like I said, I'm not using 9 right now. Everything we're using is 8. Close these. So once Docker is installed, you just click the little whale here, and he'll pop up in your little menu bar saying he's starting. And it takes it a minute to start up. And while he's starting, we'll look at the preferences. So you can start Docker when you log in. You can automatically check for updates. You can include your VMs in the time machine backups. These are Mac specific. They're not on Windows. Send usage statistics. That's actually beneficial for developers. So if you're using the Community Edition, you might want to leave that on. File sharing, so you can create some additional subdirectories that you want to share within your distributions. Your disk image, so you can set how big you want your images to be. Advanced, you can set how many CPUs, how much RAM, what your swap file is going to be. You can also configure proxies if you want to hit this externally, which once you deploy these to the cloud, you typically will want to set up some type of proxy if you want to lock down your instances. And Damien, which is experimental right now, I haven't messed around with this guy too much, but you can include some additional configurations in here. I'm going to go ahead and reset everything just because I don't want to have any carryover from my previous attempts. And boom, it's restarting. Everything's happy-go-lucky. What I like about this software, or at least this wonderful little tool they have, this interface. It's very easy, very quick and dirty to use. So once it starts up, well, it's starting. We'll click Kinematic. You'll have to download Kinematic separately on the Mac. I have not had a chance to try it on Windows, but pretty much if you, it can't use it yet. Now it should be able to retry. You have to wait for Docker to start, because what it does is it will give you all the recommended distributions that are of the Docker images that are available on Docker Hub. It's kind of cool if you want to run a little Minecraft server for your kids. You can download Minecraft, run it locally in a little Docker container, and boom, you don't have to set up a whole computer for this. You could just run it here or deploy it to a cloud base if you want to open it up for your friends. You can do MySQL. If you want to do like a WordPress container, you can search for WordPress, and there's an official WordPress one. It's real easy. You just click Create. It's going to download the WordPress instance. Takes it just a minute or so to load up. And what's kind of cool here is, boom, we now have the container. It's installing it. It's running it. And then if I want to see the web preview, and it'll walk you through, and you can set up WordPress. There's a couple additional things you have to do for the WordPress. I'm not going to get into that today, but you would essentially also need to set up a container for MySQL. So, because typically you want to run a MySQL database with WordPress, but that's what's cool about this. So you can run WordPress as one container, and you can run MySQL as another container. These containers are very lightweight, so they only are running what is necessary for that application. So you don't have all the excess bloated libraries and additional pieces that like Linux installs that you don't need. So this is very lightweight. So we'll get rid of this guy. You can stop him, remove, boom, gone. All right, so we've got Docker. Docker's installed. It's running. So right now, let's see if we have anything in Docker. So let's take a moment and go look at the command line interface for Docker. That one. That one. All right, so we see Docker running here, but let's verify it. So let's go to our command line, and to test that Docker is running, you can just type Docker, and it gives you all the commands that are available within Docker. So the option Docker command, self-sufficient runtime for containers. So you can configure, so you type Docker config, you'll have to pass in some configuration parameters that you want to add to the config file. -d or dash debug runs in debug. You can get the host listing, you can set the log levels, and versioning. So we know we've got that, and then the other way you can do it is you can do Docker -version just to see if it's running. If Docker's running, you'll get the version. Same as if you did Java version. Oops. Oh, can't run it within this virtual machine. I haven't deployed Java yet. Okay, so the other one is Docker info. This tells you everything that's running within your current Docker containers. So it tells you what's running, how many are paused, how many are stopped, how many images you have, your storage information, typically everything you want to know that's running on your current Linux installation for Docker. So here it is, it's running a Linux kit, Docker for Mac, Linux architecture for CPUs, everything that we saw by looking up here at the preferences. Now I know we tested the Docker installation by installing the WordPress, but let me show you how to do this from the command line. So let's install the Helloworld container from Docker. So Docker run Hello World. Well, I'm telling it to run Helloworld, except at the moment I haven't downloaded Helloworld. So the first thing it's going to do is it's going to check to see if the file is locally. It's not. So the very first thing it does is it pulls down the library Helloworld from the Docker site, which was similar to here. So if I actually typed Hello World, it would find it right here. And that's the guy that I just downloaded. And then it downloads it, and then it runs it. So hello from Docker. It shows you that the installation appears to be working correctly. Docker client connected to the Docker daemon, downloaded the Docker container, was able to run it, and so forth. And then the other thing it gives you says, hey, why don't you try something else? Let's try running a instance of Ubuntu. Well, okay, so I'll run it Ubuntu bash. It's going to download Ubuntu locally, and boom. I now am running a in-memory version of Ubuntu. So it's running the container right now. If I want to get out of this, I exit out. So I've now logged out of my Ubuntu. But if I do Docker again, oops, Docker info, we now see I have 2 containers, 2 stopped containers, and 3 images. Well, wait. Why do I have 3 images? Well, the first image was the WordPress that I downloaded, and the other 2 were the Hello World and the Ubuntu. To actually see that, we can type Docker, kind of like if you were on Linux, type PS, and it gives you the options. You can do containers, images, look at the commands, status, ports, etc. So nothing is running right now. So if I do Docker image list, there's our repositories. So these are all of our images, WordPress, Ubuntu, Hello World. If I actually want to see what containers are loaded, and currently there are no containers. So if I, or actually no containers running. If I want to see all the containers, you do -all, and now it gives you a list. Okay, Ubuntu was just run, and it exited. And then if I want to see everything that is quiet, so this is the very last one that ran, but there's the Hello World. So, okay, so I have a couple containers, I have a couple images. What else can I do? Well, let's see. So we could do, let's see. So let's clean up what we have here without having to do a reset. So let me go back into Docker. Let's see, Docker help. So here's all the commands that you can use from the command line. So some of the other ones we can use that we're going to use to clean up are going to be remove RM to remove the container, RMI to remove images. So where if this was just a pure Linux, if you are on like Ubuntu, or if I was just using the plain old terminal, RM is used to remove files, folders, etc. In the Docker container, RM is to remove containers, and RMI is to remove images. Now you cannot remove an image if it's already attached to a container. So you have to remove the container first before you can remove the image. So if we want to clean up, we need to do Docker container and help. All right, so the commands I can attach, run, remove, restart. Let's see, Docker container ls all. In order to delete the container, you need to have the container ID. So now Docker remove the ID. So now if I go back and I look at container's empty. Docker image. So I have 3 images. Let's go ahead and clean those up. So we'll do Docker remove image. It's also using the image ID. Okay, so now if I look at Docker image ls, we're clean. If we go back and we look here, our container is clean. Just to be safe, we'll reopen it and we have no containers running. All right, so next, let's package and deploy a simple Helloworld boot application. All right, so the first thing we need to do is we need to create a new Spring application. So we'll do Spring Starter Project. And we're pretty much going to leave the defaults here. Hello Docker Demo is what we're going to call it. Leave everything else the same. Next. And here we're going to want to do a web project. And next, it'll install the starter Spring and the starter zip. So we'll finish. This is one reason why I like the Spring STS Eclipse over just plain Eclipse. It pretty much has all these preloaded libraries for you, which is pretty cool. All right, so you got Hello Docker Demo. So we have a basic application right now that doesn't really do anything, except it does contain the web library so that we can actually do something on the web with this project. So the first thing we need to do is we're going to make this guy a REST controller. Let's think. So what I've essentially done is I've turned our project into just a basic REST application, which when you hit it from the domain, it will print out Hello Docker World. So this is just a quick and dirty test application to see if this works. All right, so the first thing we want to do is let's test it locally. So it's a Spring Boot. So here's our little boot container. So we can run it here inside of Spring. Kicks it off. Run, boom, we're up. I can open in web browser and boom, it works. Hello Docker World. So first step, we now have a working REST application. So we'll stop that guy. In order to make this a Docker container, we need to add a file to the root called Docker file. Pretty straightforward. And then the basic information you need to add to this guy is this. So we need to add the from. So tell it which version of Java you want to install with this. So we're going to do the OpenJDK 8-JDK Alpine. So it will download this container to go with our project. We're going to install everything to our temp folder on our Docker instance. Our arg is going to be a our jar file, and we're going to copy the jar file app.jar, and we're going to set the entry point to java-security endpoint file dev URL random -jar app.jar. So that's just saying the entry point to be deployed with the container. Lastly, we need to modify our POM file to actually include the Docker plugin. So the first thing we need to do, if you have installed or registered Docker with Docker IO, which I have, if you actually sign in with your Docker ID, what you can do here is within your POM file, you can set up your Docker project to actually talk to your Docker repository. So I could go to my repositories, view all. So right now I have no repositories. Again. But if I want to create a repository, I could say, hello Docker demo, and create. And boom, I now have a private, but I'll change this guy to public. Repositories. Delete. There we are. Public. You can have them as private, but since we're just demonstrating how this works, so you got hello Docker demo Insomnia 114. So what I can do is inside of my POM file, I can set a Docker image prefix, and this could be Insomnia 114, which is the same prefix here. And then hello Docker demo will be the project name that I have defined here, hello Docker demo. So then we come down here to our plugins. So we have to add a plugin now that will actually build the Docker file. We run the Maven package. All right, inside here, we're going to use the org.spring framework boot. We're going to use the Spring Boot Maven plugin. What we've added is we're going to use the com.spotify, which we're going to use the artifact ID, the Docker file Maven plugin. So that's where the Docker Maven plugin comes in. It's out in com.spotify. Current version 1.3.6. Repository is going to use our project.artifact ID. And we're going to build the arg, so it's going to be the target. What we would do if we wanted to register this or push this container out to our Docker IO is you would use, where did the prefix go? You would use the Docker image prefix in front of the project build file name. So when it actually builds the file, it will look like this in our Docker image. But for right now, I don't want to do that because I haven't configured that for the push to work yet. So we've got a project artifact, target, project build, file name. So this will just build the target. It'll be the hello Docker demo file to my target folder here. And it will also put it into my image files when I run the make file. Save my Docker file. I have my hello Docker POM file. So now what I need to do is go back out to my command line. And where am I? Okay, so I need to go to Documents, Workspace, Hello World, Hello Docker. So in here, we have our Docker file, and then we have our Maven command and our Maven shell. And we're going to want to run the Maven window, install Docker file build. And if I did everything correctly, it's going to go out, download all the dependencies, run the Spring Boot to build the Docker file. It should take just a minute. There it is. It's downloading step 1. It's downloading the OpenJDK image. Setting up the volume, built the jar file, copied the jar file, and sent the endpoint for the runtime. So now, if I go look at Docker image ls, we have hello Docker demo, and we have our OpenJDK. So now all we have to do to test this guy out is run it. Now, if you just do straight up Docker run, and you try to do the hello Docker here, it's going to run it, and it'll run it internally on its own IP address, which you won't have access to. You can connect to it only through the command line Docker commands. But if you want to actually hit this website from your local machine, you have to set the port mapping. So this will port the Docker IP address to localhost 8081. And the reason I'm changing 8081 here is I want to show you that you can run both your local instance from Spring Boot as well as your Docker instance at the same time. So we'll kick this guy off. It's running. And you're okay to cancel out. If you do Control-C to kick you out, it's still running. So if you actually come in here and do Docker PS, our instance is still running. It did not die. So that's one of the cool things you can do. So you can actually stay interactively, or you can jump out and your session will still be running. The other thing, which is cool, it's running right here. So if you go out to the Kinematic Dashboard, you can see, hey, our container's running. Here's our logs. And here's a web preview, Hello Docker World. So we actually don't even have to load the browser, but I'm still going to kick it off just for kicks and grins. So localhost, Hello World, Hello Docker World. Now, if I go back over to 8080, it's going to fail, but that tells me now I can come back over here, restart my Docker instance inside Spring. So now I have two Tomcats going. I have one is running on my local machine, and I have one that is running within my Docker container. All right, so far so good. So that was a long way. So the real parts to look at is you need to make sure that you have this plugin added to your build properties inside your POM file. If you want to connect this to your Docker IO repository, you need to add the prefix, your Docker image prefix down here. And then you could do, I think it's Docker file push. I'm saving that for a future lesson, so I won't get too much into the actual repositories right now. So you need, essentially in your POM file, you need this plugin. You need to add the Docker file with at least these settings. Now you can change the volume, you can change wherever you want to store this container once it's running in your Docker. And then we just have to have our application do something. So we have Hello Docker World. So that was starting from scratch, a quick and easy way. Now, let me show you the super easy way to get a little Docker container going in Spring. Now, see, it won't let me delete it because it actually is still running. So I'll come back out here. We're still running. So Docker stop, and you need to use the container ID again. So it's stopped. Docker remove, and then Docker so let's get rid of these guys. So actually, by dropping the container now, it also dropped it from Kinematic. So if we do Docker image ls, okay, we're starting from scratch again, so everything's good. So come back out here to Spring STS. And let's do a new project. So let's cheat. Let's use one of the Spring Getting Started projects. So give it a second to load the guides. So you can actually type a Docker in here, and they have a Spring Boot Docker example, which if you want to kind of walk through what we just did, here's the basic steps here. But pretty much the takeaway is you need the Docker file, and you must add this configuration, this plugin to your build. So then if you have this, so this guy's slightly different because he's just built as a demo and he includes this documentation. But under here, the application YML contains the configuration file for this Docker build. So if you want to change the port, you need to change the port here, or like I did at the command line, when you kick it off, you can override the setting by setting the port there. You can also change some endpoint security here as well within this particular example. But their Docker file has the exact same examples that we use. One of the other things you can do, instead of copy, you can do add. So you can actually add multiple jar files to your container and the POM file. Their POM file contains one additional piece, which is kind of interesting. If you look at the plugin here, they actually unpack the package, unpack it, and then they have the configuration for the artifacts and jars. So they're actually defining a few other settings here. And their application, just like ours, hello Docker world, it's just a little rest. And then if we go out to our command line again, we want to go to the complete. And in here, we'll run the Maven install Docker file. This command is the exact same command you use for all Maven builds. Let's read through. And done. So if we look at Docker again, there's our Docker image. Notice how they prefixed it with the Spring IO. So we are not with the Spring IO project, so we can't actually push it. But since I have one as Insomnia 114, if I changed it to that, I could push it to the Insomnia project with a couple additional configurations. All right, so we want to run this guy. So take this here, Docker run. Jump out of there. Look at our container. Oops, I accidentally killed it. Let me restart it. And let's go look at it. So we pushed it. So here's the rub. So I ran it, but I didn't set my ports. So in order to actually connect to this, I have to run it. I'd have to connect to it locally. So we'll shut this one down. So we'll actually kill this container. So we'll stop that one, kill that one. It's now gone. So if I do Docker container ls aq, there are no containers. So when we do the Docker run, we need to include the -p for the port forwarding and set the image to our image. There we go. So now if I come out here, and there's our Hello Docker World. So that's it in a nutshell. So let me jump back over here. So does anyone have any questions? All right, since there are no more questions, thank you guys. I appreciate your time. I'd love to discuss any future questions. If you have any other questions, comments, suggestions, shoot us a line at any of these methods, info@developernerd.com, developernerd.com/contact-us, on Twitter at developernerd, or on Facebook at developernerd. Our goal is making every developer better. Have a great day.